So in this example, I'm going to start off with some basic warm-up. We're going to look at the graphs of exponentials versus logarithms. And we've already done exponential graphs in a previous lesson, but I'm just going to graph one here for argument's sake. Let's say we start out close to 0, and then it starts to rise, and then it really takes off as your x values get large. So we're going to call this, I'll just call this f of x right here, and we'll say this equals, I don't know, 2 to the x. Okay, well, we've talked about how logarithms are the inverse of exponentials. So what does an inverse function look like? Well, it's flipped over this line, and let me actually put a line in here. Remember, we have a line y equals x right here. You can barely see that. I don't want to draw this too dark. But this line that I'm drawing right here, that diagonal is what you flip an inverse around. So if you're trying to graph an inverse function, you want to draw the mirror image around that diagonal. So the inverse of this black function that I drew first is going to look something like this. Okay, it's going to come up. No, that stinks. Let's try this. Let's try to do a little better here. All right, it's going to come up like this, and then go out. Okay, so that is the inverse of f. Okay, the inverse of f of x. And it's a logarithm, so I'm going to just go ahead and write this form. It's going to be the log base 2. Remember, it has the same base as the exponent had a base. And the argument is the same, x. Okay, so there's what an inverse of an exponential looks like, a logarithm. Now, I could draw another exponential here, and let's go ahead and do that. This time, instead of 2 of x, I'm just going to make believe that I'm drawing 5 to the x. Okay, so 5 to the x starts out smaller, and then it goes bigger. And the reason for this is, when you have 5 to a negative power, that's like 1/5 or 1/25. Those are small numbers compared to 1/2 and 1/4. But as your exponent gets bigger than 1, this function is going to rise very quickly. Okay, so over here maybe we have 5 to the negative 1, 5 to the negative 2, and over here 5 to the 1 right there is bigger than 2 to the 1. 5 squared is bigger than 2 to the 2. Okay, so this is, you know what, I'm not going to use f. Let's call this function g of x, and I'll say g of x equals 5 to the x power. Okay, so we can find the inverse of g of x, just like we found the inverse of f of x. Bear with my artwork here. This isn't going to be perfect, but just like it starts out even closer to 0 in the exponential, the logarithm will start out even closer to 0. And that's going to come up across this point, and it will be, it'll still be going up here, but it will be a flatter function. Just like 5 to the x in the exponential dragged the curve here and it made it steeper, logarithms will drag the curve lower down to the x-axis. So let's try to write the equation for this. Here we go. So this one, what was that on g of x? I'm going to say the inverse of g, which is logarithm base 5 to the x is in red, and in black we had base 2. So there's the general shape of logarithms and exponentials. And something actually interesting happens. I don't want to crowd that graph with it, but if we had a logarithm which was, so here's your basic logarithm, right? That's going to be logarithm of 2, or base 2 of x. What would happen if I was trying to draw logarithm of 1/2 of x? Well, that's an interesting case, and it looks kind of like this. And I intend to draw this as the exact mirror image, because logarithm base 1/2 of x is a vertical reflection. Funny things happen when you do vertical reflections on logarithms, and the effect here is that this vertical reflection, which we're used to just being a negative sign, right? What this is it changes the 2 to a 1/2. And likewise, if it were log base 5 of x, it would change it to log base 1/5 of x. That is what a vertical reflection does to the logarithm graph. So I think that's enough for now. We'll get into more logs later.